First, we click Geometry and wait for the program to open. In the geometry, we will draw the figure. Units, change it to millimeter. XY plane, look at, so we can look at the side view. Sketching, polyline. We draw a rough figure, a rough sketch of the converging diverging nozzle, and after the rough sketch we can adjust it with the following settings. Close the end by right clicking and choosing close end. Then we go to constraints. From constraints we choose symmetry to symmetricize the unsymmetrical lines so we can end up with a symmetrical shape. So you click the center line and the top and bottom nodes to symmetricize them. Then we go to dimensions and choose the length so we can specify the length of each side of the nozzle. We start with the middle and until we are done with all the sides. After specifying the dimensions, we specify length 1, length 2, length 3, length 4, and finally length 5. Then we go to concept and choose surface from sketches. Then we go to XY plane and choose sketch 1. We go down and we apply to choose the sketch. Then we generate. Next, we need to separate the converging and diverging nozzle. We go to sketching line and we draw a line in between the converging and diverging nozzle. Then we go to tools and choose face split. Here, face split. We choose the feature of the converging diverging nozzle and we click apply. Then we go down to tool geometry, we click the nodes of the line that separates and click apply. Generate to generate the result of the splitting. As you can see now, we have two sides, a converging and the diverging. Then we go to sketching line. We want to draw a vertical line beside a converging nozzle and a vertical line on the diverging nozzle. As you can see, the lines are not parallel. So we go to constraint, we choose parallel, and we parallelize the two lines. Then, after choosing parallel lines, we need to specify the dimension, the distance of this line from the center, or from where it is separated. We choose the distance to be 5 for both lines. Now we repeat the face split step that was previously done. We repeat it because we want to separate the converging diverging nozzle into 4 parts. That's why the two vertical parallel lines are there. As you can see, this is exactly what has been done previously. We just want to split them into 2 more parts, so we are left with 4. Generate. Now we will check that we have 4 parts. 1, 2, 3, 4. We go to File and close Design Modeler to move on to Mesh. Now we right click Mesh and choose Edit and wait for the software to open up the meshing part. Now we are in the meshing part. We right click, View, and choose the front view. As you can see, here are the 4 parts we had. We go to Mesh, right click, Insert, and choose Method. We select the meshing. Oh, sorry. We have to select the region first to apply the meshing on it. We select the region and click Apply. Then we change the free face mesh type to Quad Tri. Next, we select all the vertical lines of the converging diverging nozzle. Press Ctrl so you can select all the vertical lines of the converging diverging nozzle. Then right click, Insert, and choose Sizing. We change the type to number of divisions and we set the number of divisions to 30. Now we do the same thing with the slanted lines of the converging diverging nozzle. So we press Ctrl and we choose all the slanted edges of the converging diverging nozzle. It's the same procedure. After we're done, we choose Insert, sizing, and similarly we change the type to number of divisions and we set them to 20. Then we go to mesh, right click and update. Just wait for it, and here we go, we are ready. Now we have a mesh. Next we choose the face view and we select all the 4 separate parts. We right click and we choose insert and meshing, face meshing. We go to mesh, right click and update. As you can see now, we have a very uniform and nice mesh. We select the inlet, specify it, create name inlet, then we do the same for the outlet, create name selection outlet, and we do the same for the slanted sides. We select them all and create name selection and label them as walls. Next, we choose the name selections, inlet, outlet, and wall, select them all together with control, and we exit, close meshing, right click mesh and update.
After the meshing is done, we now go to the setup. We right click and press edit, and the window we get, we just press OK. We keep it as 2D. This will take some time, and we should get this window, and in the general tab we select the type as density based, and the model we need in the model tab we make the energy on, and then we go to the material and select air as our fluid, and we make it to behave as ideal gas. Then we define our boundary conditions at the inlet, but before doing that we first have to define our pressure inlet, the type as pressure inlet, and then we define the pressure as 300,000 Pascal. We then define our type as pressure outlet, and uh, and then we keep our gauge pressure as 0. Then we define our wall boundary condition, and we make it stationary, and define a no slip condition, and we press OK. After that we go to the monitors, press create, and then we select print, plot, select the wall, and press OK. This will add a monitor to our side walls, and then we will go to solution initialization and select standard initialization and compute from inlet, and then we will press initialize. Before doing that, we will go to our reference values, and we will over there we will define compute from as inlet and reference zone as solid surface body. Then we will do the solution initialization at inlet. After that we run calculation, and we define the number of iterations we have to do as 500, and we calculate. This is how the solution is converging, and this is the final plots we get for the scale, residuals, and convergence history. After that we go to graphics and select contour plot. We select all the walls and we display the pressure contour. Then we make it filled, and then we display it again, and this is how the final plot looks like. After that we select we select a Mach number, and this is the Mach number contour plot. As you can see, at the throat the Mach number is nearly 1, and at the outlet it is at the maximum, and for the pressure it is the opposite. It's maximum at the inlet and minimum at the outlet. Then at the end we go to plots. We select XY plot, and We first plot for the static pressure at the walls, and we press plot. This is the graph we will get. As you can see, it keeps on decreasing from the inlet till the outlet. After that, we select the velocity, and for that the velocity, the Mach number, and then we select walls and plot, and this is, as you can see, it is inversely proportional, as the Mach number is highest at the outlet and lowest in the inlet. Then at the end we go to the results section. We bring the we change our axis, we bring it to the 2D, and then we define a new streamline function, and the number of points we will take it as 50, and we will start from inlet. We press the apply button, and this is the plot we will get for the streamline. Just to show you how it works, we will change the number of points and then apply again, and this is how the stream function is changing. And then we will go to tools, animation, and we will show you how the graphics animation of the streamline looks like. Thank you.